Section 3.4 is going to allow us to use our derivative rules that we've learned in the previous sections. Yes, it's going to be lots of word problems, but you're going to see some of the same words. We're going to use that word marginal quite a bit. All right, so we're going to talk about the cost and the profit and revenues, much like we did in Chapter 2. So what is the marginal cost? It is the cost in producing one more unit. Right? It's approximated by the rate of change. Now, when you hear that word, rate of change, you should think of derivative. Now, the marginal cost is the actual cost of producing one more unit, but instead of trying to use that, we're going to use the rate of change of the total cost function. That would mean the derivative of the total cost function. So, marginal is pretty much the same as derivative. So the examples I have chosen are out of your book. They should be very similar to the ones you should see in your homework on the computer. All right, so let's look at number 4. We have somebody making some microwave ovens, and we have a cost function. All right, so what is the actual cost incurred in producing or manufacturing the 101st oven? Now, most students would think, well, you just plug in 101. No, that's not quite it. If you think about, this is the total cost. So if you plugged in 101, that would give you the total cost of making all 101 units. So if you want the actual cost of just the 101st, we need to take how much it cost to manufacture all 101 and subtract how much it costs to make the first 100, and then that difference would give us the cost of the 101st unit. All right, so we're going to need a calculator here. So I'm going to calculate the cost of the 101st unit. The cost of manufacturing 101 units is $16,714. The cost to manufacture 100 units is 16,600 units. And so if you subtracted those, the cost of the 101st unit is $114. All right, so that's what you want to do for the 201st and the 301st. And so again, we would say that cost minus that would be the cost of the 201st unit. And I'm going to hopefully know that you can punch those into the calculator, and that is going to be approximately $120.06. And so again, we get to do for the 301st. And so this would be, again, the cost of the 301st unit. And again, we would evaluate the function at 301 and then evaluate the function at 300. And that cost would be about $138.12. All right, so now let's see what else are we asked to find. What is the marginal cost? So now we know exactly how much. The idea is they want you to use the derivative to see that it would be a very good approximation, right? So what we have to do, since we want the marginal cost, is we have to come back up here and we need to take the derivative of the cost function. All right, so part B, the derivative of the cost function. Now remember, we're just going to use the power rule, so we can take this exponent of 3 and multiply it down in front, and we're going to get 0, 0, 0. 2 times 3 is 6, and of course 1 less. Then we have 0.12x plus 120, and then the derivative of 5,000, of course, is 0. So that is our marginal cost function. So we can put in 100 and evaluate that function at 100, and we would get, we need to take the derivative. We need to plug a 100 in there, and we would get $114. Now you can see that that is exactly correct. All right, a very, very good estimate. Then we can take that derivative and put in the 200th, and we will get $120, comparing it to $120.06. And then the marginal cost of 300 units is $138. All right, so let's see. What are we comparing? We're comparing the actual cost of the 101st unit, the 201st, and the 301st by taking the difference of those costs. This, we're getting the average rate of change at 100, 200, and 300, or the slope of that curve at those particular points. All right, so let's look at number 6. We've got a Thermo master company, and we have, again, a cost. So this time they're asking us for something different, the average cost. Well, if you think about what average means, it means you would add up everything you have and divide by however many units. Well, remember, X is the number of units we're talking about, and so that's what we would need to divide by. We would take our total cost and divide by the number of units. And that is going to be the average cost. So when it says to find the average cost, this bar on top of the C is the average cost. So we take the cost function and just divide by X. That's it. Okay, we could maybe separate that. It really doesn't matter. And we could say 5,000 divided by X and 2X divided by X. The X's would cancel. But either one of those answers would be very acceptable. Okay, so part B, find the marginal cost. That would mean to find the derivative. Okay, so let's see. How can we find the derivative of this function right here? Well, how about let's rewrite this with putting the x up on top and using a negative exponent. All right, so when we find the derivative, we can use our power rule. So that's negative 5,000, x to the negative 2. Remember, that's 0. And then let's go ahead and rewrite that and bring that x down to the bottom again. So that is the marginal, when you see that, think derivative, average cost. Now it says interpret your results. You know, that's a big, vague question. Interpret your results. Well, let's see. I want you to notice that this fraction is always going to be negative. So no matter what x is, the marginal average cost is negative. What does that mean in the real world? I'm not real sure, but this is what I am interested in. All right, so let's put a little bit more into it. We're going to be talking about revenue and profit and all of that we should have learned from Chapter 2. So let's see, what have we got here? That we have a demand function, where P denotes the speaker's unit price and X denotes the quantity demanded. So find the revenue. Okay, so what is the revenue function? Well, how do you make money? You make money by selling products. All right, so we want to multiply how much it costs times how many units. Well, if P denotes the unit's price and X denotes the quantity demanded, it seems like to me you would multiply price times the units. So in other words, in this case, we'd need P times X, or negative 0.04X, place 800 times X, and that would be your revenue function. Right, so part B, the marginal revenue function is just the derivative. So again, just using that power rule. And then part C, compute the derivative at 5,000. So we would plug in 5,000 for X. I believe you would get 400. All right. Okay, so now it says interpret your results. Let's see. That means when you get past making 5,000 units, that you're going to make in revenue, you're going to bring in $400 for each unit. Let's say we have this cost, okay, so we have another speaker system, and we want to find the profit function. All right, so recall that the profit is going to be your revenue minus your costs. How much money you brought in, but how much money did it cost you? That's your total profit, right? So let's see. So if we have a cost function here, what is our revenue function? This problem is referring to the previous one we talked about, those electrostatic speaker systems. All right, so I need to use the revenue function that I found in the previous example. All right, so now that I have that, then I can figure out that my profit function is going to be my revenue function minus the cost function. And let's go ahead and distribute that minus sign out, and let's go ahead and collect like terms. Let's see, 800 minus 150. I hope that's 650. And that is your profit function. All right, so let's see. Part B, of course, is going to find the marginal profit function. That's just the derivative. All right, and now we need to compute the derivative at 5,000 and at 8,000. I got a marginal profit of $250 for 5,000 units, but I only got a marginal profit of $10 for 8,000 units. What does that tell you? So this one again has all the stuff in it: cost, revenue. Let's see, so this time we're making digital TVs, and let's see, we've got a price, so we've got a cost, and what do we want to find? The revenue function and the profit function. All right, so remember, the revenue function is going to be what your price is multiplied by the number of units you've sold. So let's see, what was the price? They've given that us in this function, and then we want to multiply that by x. And then our profit function, remember, is revenue minus the cost. Ooh my, okay, minus all of that cost function. So let's see, I think I need a little more room here. So negative 0.006 x squared. And now I want to make sure I distribute the minus sign to all of that. So the next one's going to be a plus 0.02 x squared, and then that's going to be a minus, and that's going to be a minus. So let's see if I can clean that up. 3, 4, 5. I hope I've not missed any zeros. Okay, and then let's see, that's okay, I think that's my profit function, as long as I've not missed any zeros. All right, let's see. Now I want the marginal cost function, marginal revenue, and so forth. Okay, so all of that means to find the derivative. So again, just using the power rule, it's going to be I really think that's 5 zeros. 1, 2, 3, 4, 5. Okay, that's my marginal cost function, marginal revenue, and then I needed my marginal profit function. And then it wants us to substitute in 2,000 for all of those. All right, so plugging in 2,000 into each of our marginal functions, we have a marginal cost of $64, marginal revenue of $156, so that gives a marginal profit of $92. All right, now this is asking us to refer to the last exercise, so it says to find the average cost. All right, so remember, the average cost is just the cost function divided by x. So remember, that cost function is all of that divided by x. Now I would go ahead and reduce that, and I'm going to go ahead and write this as x to the negative 1. And the reason why I'm going to do that is because the next question says to find the marginal cost, average cost function, which means I'm going to have to take the derivative of that. And remember, now you can use the negative exponent, you can leave your answer like that, but keep in mind that you could rewrite that as x is in the denominator to the positive 2 exponent. So part C says we want to compute the marginal average cost function at 5,000 and at 10,000. All right, so when I put in 5,000, I get a negative value. When I put in 10,000, I get a positive value. What does that mean? It means while we're producing up to 5,000 units, our average cost is going down, but at some point around 10,000, a little bit less, our average cost is going up. So in a business model, what you would try to do is you don't want to keep your cost rising. That's not a good thing. So you want to try to find that equilibrium point where you're not going to increase your cost. So here is an example where we've got a quantity demanded related to the unit price. We want the revenue function. So let's look at this one. We have a quantity demanded, and of course X is the number of units. So to find the revenue function, you want to multiply the price times the amount of units. So I would take this and multiply it by X. So the X is just going to go in the numerator, and that's my revenue function. Okay. So now I want to find the marginal revenue function. So I want to take the derivative of that. The reason why I've chosen this problem, it's very close to number 17 on page 207, and it's probably close to one of the problems in your electronic homework, is that it's going to give us the opportunity to practice that quotient rule, which we don't get a lot of practice of. So let's remember that quotient rule. So we have our function, and I'm going to take the bottom and the top, and then take the derivative of each of those. All right, so my quotient rule, remember we're going to multiply those together, and then we're going to multiply those together, but we're going to subtract that, and then we're going to divide by the bottom squared. Now that's the quotient rule. The rest of this is just really I'm going to multiply stuff out and collect like terms. And that would be my marginal revenue function.